Hello, everyone. Can you hear me? Yes. Yeah, we're in good shape then. My name is Kellyn von Gorman. I'm the Technical Intelligence Manager for a company called Delphix. Virtualized data, doesn't matter if it's big data, relational data, flat files, work in database administration for about 20 years. I'm a multi-platform DBA. I've worked for Oracle in their strategic customer program. I was a DevOps engineer. I am now about to leave and go to Microsoft. So I will be on their AI team, starting out in another 5 days and counting. So I'm a little stressed, a little nervous. This is the end of a 10-day talking tour for me. I was in Cleveland at an Oracle event and then went down to Dallas for 2 Microsoft events and then back here at Boston. I am so ready to go home tomorrow. I am not going to lie to you on that one. I'm known in a number of arenas. In Oracle, I was an ACE director, which is a peer recognized program within the ACE community. I am also an Oak Table scientist. This is, they're Oracle scientists with a drinking problem. I think that's the best way to describe them. It's anybody, that was an Oracle DBA that laughed, isn't it? Yeah. There's about 115 of us in the world, and I'm one of the 5 women. There's not a lot of women there. I'm also an IDEA ACE, which is a Microsoft peer recognized program. Like I said, it's kind of weird where my world is because I just like data. And I'm both the president of my SQL Server user group and my Oracle user group. I mean, we got cats and dogs sleeping together. It's bizarre. But I do a lot with STEM education. I was one of those kids that I got in trouble for taking electronics apart. So when Raspberry Pis came out, this was a perfect excuse for me to start working with this stuff. So I've been teaching kids Python and Raspberry Pis, and I was really just thrilled when I was coming home on the plane about 3 weeks ago, not even that long. And I went through this month's issue of Wired magazine, and they had, who gets Wired? Anybody get Wired? There was an article on DTech University on the Oracle campus. Did anybody read that? Has anyone seen that? It's an awesome article, and the first girl that they have right there in the front, I taught her Python 3 years ago when DTech University was opening up. And Vani is awesome. She is, I'm just thrilled. I take no credit, but I will tell you, she was not looking at tech back then. And I'm like, yes, yes. They thought I was weird enough to follow in my footsteps. So let's talk, to start our talk here. DevOps, I mean, how many of you are using DevOps in your IT group now? I've got a few of you. So DevOps is a big deal, and for me, when they came to me, I was already a DevOps engineer and I didn't even know it. I was automating everything around me, making it simpler to utilize data. Excuse me, even when I was at Oracle, I was virtualizing databases and trying to speed everything up, and I automated everything. The reason I started using Enterprise Manager was because the other DBA that I worked with that loved to death would be like, Kellyn, love your scripts, but I don't want to troubleshoot them at 3 a.m. Automate it all, so that was kind of my world. Everything is getting more in demand. We're starting to feel this pressure, and every conference I went to, no matter if it was a big data conference, a relational conference, it didn't matter. Everybody seemed to be having the same problems. So I recognized that we needed to marry these 2 things. We needed to marry data and DevOps. And that's where this is going to get into a theory or a definition that I don't know if you've heard of before. And it has to do with DevOps and data gravity. So data gravity is the ability for data to attract everything to it. It doesn't matter if we're talking about, applications and services, just about anything, it's all attracted to it. And then there's a secondary definition for this, that data itself has weight. Data is heavy. It pulls everything down and makes it impossible to move forward. Now, I felt this very painfully as a DBA. Every time that I was working with data, I realized this. And what you're noticing is that a lot of, magazines and online articles are starting to discuss this. If you even look at Forbes, they forecasted by 2020, which seems to be a real pressure date there, that every human on the planet will be creating 1.7 megs of data every second. that they're alive. You start to calculate this data, it's pretty huge. It's not all going to be in big data. It's going to be some of it in relational, some will be in flat files. It'll be all over the place. And as a DBA and a DevOps engineer, I'm going to be responsible for some of that. So I was trying to figure out how to deal with this. We start looking at how many people have cameras just, on their phones, and they're uploading this data to the cloud. This is even bigger data. Anything to do with audio, video, this has to be stored somewhere, and people are going, we'll just store that in the database too. So this is that pressure that I'm starting to feel, and this is going to be a use case story for a company that I've worked with. They are out of the Denver area, and we're going to use some of the people that are in there, and I've changed their names so they may remain innocent. But Dave here, he is a data scientist, and he's trying to do more with DevOps. They recognize after going to conferences that they can increase their revenue, that they can increase their collaboration, that they'll get out of silos, that they may be able to move faster. And of course, again, that company is looking, I just want the money. So they're starting to look into this. They hire a Scrum Master, and they've decided Scrum is what they're going to utilize. They want to see an increase about 20% in productivity. They want to see a 25% increase in collaboration. And this is going to be something that George is going to help them with. Now, to do so, if any of you are starting to look at how to figure out what you're going to do and how you're going to pick those tools, because even though tools aren't DevOps, it is part of that solution. You have to have a really good set of tools to help support not just that change in what people are doing, but that change in culture. And culture is a big deal when we start talking about DevOps. Now, this link that's down here on my slides, this is to the periodic table of DevOps tools. Have any of you seen this before? Have anyone? This is an awesome site. It's by Zabia Labs, and you can go out there, and it's very interactive. My squares are a little off on this, I apologize. But for Dave and George, when I started working with them, I pointed this out and said, you can start figuring out what tools are going to work best together. It's not a one-for-one comparison. The second row in from the left is databases, and I can tell you my company's on their Delphix, but so is DataCal, and they're our partner. They're not our competitor. So understand that looking at what these are based off of is important, but it'll actually take you through, and you can click on each of the links, look at the product, go into deeper research on it, and start to figure out what your DevOps solution is. And this is one of the things that George started to do. He figured out that they were going to use Jenkins, they were going to use Maven, they were going to use AWS for their cloud, and they started to pick out what solutions were there. Then they started working on the actual Scrum. Now, if you've worked in Scrum, one of the things that you'll notice is that you got your entire burn down list. These are the things you want to accomplish over a period of time. Now, any Scrum is going to be about a 2-week cycle. These are our sprints. And they started to figure out what their sprint planning is, what their backlog is, and started to do their daily stand-ups and figuring out what they were going to accomplish. Now, as they start doing that, they do their burn down chart. They try to see how much are we going to accomplish. They start to check those off, and they work with the users to ensure that they have software that's working at the end of this. George is heading up those Scrum meetings. Now, I will tell you straight out, I have marketing people at Delphix that think they're doing stand-ups, these 5-minute meetings every day that are supposed to say who you're working with, what you're going to accomplish, get out the door. Go do that. Theirs last about 20 minutes. No, that is not a Scrum stand-up. So this is kind of a buzzword, but know that these are very valuable when we're talking about these Scrum meetings. And they were starting to get the hang of this. They were figuring out, we're going to go forward, we're going to be able to do this successfully. The problem is that all of their developers and their data scientists and their testers and everyone needed access to their own development environments. They needed to have access so they can test everything out. And as fast as everything was moving and as collaborative as everything was going, they found that they were hitting up to this bottleneck. Dave also wants to be able to test his own scripts. He starts to figure this out, that he is running up against testers and developers who are in the environments already. If he goes and makes these changes to the environment, it's going to hit up into breakage on that system. And then the DBAs or the data scientists or whoever else is responsible for this needs to go back and then fix the environment. And this is taking a lot of time. You end up with a scenario that looks like this. So at the very top, you're seeing your actual data cycles and the development cycles, and you can see how much is being taken by the refreshes and the builds of the development environments, how to get that data to them. Where the application tiers are able to be dispersed very, very quickly, the databases aren't able to keep up. Their flat files for big data aren't able to keep up. They want to get to something that looks more like the bottom. They're starting to feel this impact where they're not able to move forward at the speed and the development cycles that they want. This is a huge headache for just about every company that I've been part of. And I know this because I spent most of my time in very large databases or big data. This was always the biggest headache. Even when I went to these big data conferences, I would hear data scientists go, well, I kind of tested it on a small subset of data, and I'm hoping that it will run in production. Can't guarantee it, so it may go for a while and then fail. So what they end up doing is that without a self-service portal as well, the developers and testers are even putting more pressure on those DBAs, more pressure on the IT people, the infrastructure snapshot people, whoever's responsible for providing those environments. We realize that they're chained to these operations groups. George and Dave and the rest of the team is really frustrated, and they're not sure what they can do to actually get past this. And what's interesting now is that they're being pushed towards the cloud. With AWS, and it doesn't matter what cloud provider you're seeing, they are very focused on those developers, on those testers, those data scientists, with the idea that you can keep just deploying how many you need, how many environments you need, scale it up. Now, for a DBA, there's going to be a little bit of an alarm that goes off. And the reason is because we remember the days when groups had extra money in their budget. They would buy a server, they'd put it under somebody's desk. A developer would start developing on it, and all of a sudden it would become mission critical, and then it was my problem. Didn't matter what platform it was, didn't matter what application was accessing, how it had been built. I'm now responsible for supporting that. Now, this is something that we see everywhere. There is a company that is in Denver that used to be Arrow Electronics that's become Arrow Cloud. They have found that they're doing 30% of their business auditing cloud environments. They've also found that 80% of them aren't viable. So instead of doing it right, they're doing it twice. This is the reality of the world that most of us DBAs and infrastructure and security specialists are living in. And with GDPR, what are we on? It's the 23rd? We got 2 days, people. 2 days before GDPR goes into effect. GDPR going into effect, when we start talking about all the security and the breaches, this is really a big, crucial moment for a lot of us. We're feeling this pain. So how do we become part of this, and how do we help get data to the cloud, get data into environments, and get it farther along? Because data causes friction. This is this pain we feel. We want to get those environments to the developers and the testers. We want to be able to get data scientists to have as many environments as that you need to run analytics reports, to run whatever they have to do. And yet we are stuck with this challenge. We're finding that 80% of the time the developers and testers aren't actually able to do what they should be doing. They're finding busy work to keep them busy while we refresh environments. So this is kind of painful. But lucky for this company in Denver, the DBA did understand database virtualization and containers, and that's really the source of this solution. Now, the way that data virtualization is a little different is that we're not just virtualizing a lot of resources and sectioning it off and saying, you get this piece, you get this piece, you get this piece. It's a little different. Older cloning methods, which are trusted by DBAs, are kind of slow and archaic. It's very time consuming. We're making a full copy. So a lot of times we have to wait until infrastructure people give us extra storage. We have to wait until somebody has given us the okay to do so. There's all these different roadblocks. And that's why the cloud is done as well as it is in a lot of instances. Now with virtualization, you're creating a golden copy. You're creating, usually it's actually deduped, it's compressed in many of these cases. There are a lot of technologies that'll do this, but then you create pointers along with the front-end duplication of that database platform. And most of the companies that you're going to hear me actually refer to do this for a number of different companies. It's not just one. It can be done for SQL Server and Oracle and Sybase and Postgres and flat files and all of it. Then you create as many as you want. This is just one as a set of companies that you can look at. This is on the SQL Server side, so like Rubrik SQL Mount. Redgate SQL clone. Windocs is, of course, a Docker version of this. Actifio and then Delphix, who I work for. On the Oracle side, we can talk about companies like Veritas, Velocity, Redgate SQL clone. Oracle has 7 different virtualization tools. So if you're on an Exadata, you got Sparse clone. If you're in ZFS, you got Snap clone. You got Enterprise Manager, you got Thin cloning through Enterprise Manager. There's GDB clone and Snap clone copy with multi-tenant. There's tons of these. But the ability for the DBA, ability to actually virtualize these environments are huge in the way to get data into the DevOps cycle. So the way that this data, why it is different and important is that it kind of kills 2 birds with one stone. Most DBAs are only as good as their own backup. I'd like to say they're only as good as their last recovery. And most of these work with the native backup technology. For Oracle, we would be using RMAN, which is what most of them do. On SQL Server, it could be NetBackup. It could be whatever backup format they use. To create a virtualized environment, you're actually doing a recovery. You can even see it in the back end of the logs, the actual recovery process that's going on. So 1, you're testing the backups, which is something most DBAs don't have time to do, especially as busy as they are. Many of these tools have the ability to support and create a self-service portal, which means that you're not dependent upon your DBAs so much. There are limited roles and responsibilities that you can give to the developers and testers so they can take care of things. You're going to also see there's version control. We don't think about that too much, that the data has to be controlled as much as the actual code. When you're releasing something to production, often there's changes to that data, and to be able to take a virtualized environment, check it into Subversion or check it into whatever repository you're keeping is really nice. It's a nice change. The ability to deliver a virtualized environment when the developer says, you know what, I know this worked for you, Mr. Tester, but it didn't work for me, and I'm going to deliver the virtualized database for you so you can test it out on the copy I have and explain to me what's going on. To give you an idea of what this looks like, we have a 1 terabyte production system. I'm going to put my Delphix engine on it, okay? But like I said, all of these pretty much work the same. It doesn't matter where you're looking at this. We take a database and we compress it and dedupe it, so it goes down about 600 gigs, that 1 terabyte environment. And then I'm going to create as many environments as I want, okay? I can do this for 10, 30, 50 of these. Doesn't matter. I have some companies that are creating thousands of databases every single week, and they can control that sprawl. It's a virtualized environment. These are all read and write too. Keep that in mind, and that's how most of these technologies are. Doesn't matter if you're talking about, AppSync, EMC, NetApp, any of these things. They are all virtualized and capable of doing this. You do have the front end of that database still there, the memory processes, if they have any kind of logging, so transaction log, redo log, all of that. Those are still physically there, and they will take space because they're going to grow. It's a read and write environment. You're going to have all of the memory allocation that you would need, so you're going to need more CPU. You're going to need more memory, and you need to make sure that you've got fast network, because the network is definitely our last bottleneck at this point. It's called I/O on demand. And this goes for flat files too. So those of you that aren't in relational worlds, that are talking about big data or have just outside data sitting in these flat files, you're able to do the same thing, where you would be able to create pointers and then have as many copies of this data that you want. I took, they're not really big data as far as I'm concerned, but there was a story out of Time that talked about government data that was out there and that they couldn't move as fast as they wanted to. And at Data Summit, or I'm sorry, not Data Summit, it was Data Platform 2017 last year, I was able to take those files and deploy 300 of them, of these 16 gig files, in less than 2 minutes and get all the developers the access they need to the full data sets. Mark ends up then automating his deployments. Most of these kind of these platforms and everything have the ability to plug into Jenkins. They have the ability to have a command line interface so that you can automate it all. A GUI is fantastic when you need somebody to do something one-off where they don't have those technical skills to write things, in a scripting method, but all of these have the ability to work with Python, with Jenkins, from a command line interface. So you can make it more powerful, so you can use it at a level that needs to grow with you. It scales up. You can actually check in the scripts that go along with this and reuse them with reference files that will work much better. The virtual environments use little resources, so you're not going to need as much. You're not going to be going to that infrastructure specialist and say, I need more space, I need more space. And this also means something for the cloud as well. Second thing Mark does is he's now looking at containers and data pods. And pods, of course, comes from Kubernetes. This whole challenge when we start talking about containers is that many times it was never a choice of me running a script in a database or somebody just releasing a file out on a server. It was a package. It needed to be released all at once, and it needed to be rolled back if something went wrong in all these different tiers. This is something that containers really control very well because you can package it up and deliver it wherever you want. As we were talking about, development is never just one tier. With the introduction of the cloud, we're seeing about average 60% of customers on 2 to 6 clouds each. We are seeing customers who are saying, you know, I started out in AWS, but I decided I'm going to go to Azure, or I started out in Azure and I decided to go to Google. And you need to be able to move those. If the data is virtualized, it's much easier to move because, as we talked about, that network is kind of the last bottleneck. It provides more value to the business because it is one unit. It isn't spread all over, and you're not missing things when you actually go to do a release. So the way a data pod would work is that we would package it as a template. We would take that template and we pump it in through a Delphix engine or whatever engine. Like I said, just about all these technologies work the same. And then once it's virtualized, you would be able to deploy it wherever you need to, including in the cloud. And this one here, the example that I'm showing here, is just deployed through Jenkins. So I can automate this and do it at whatever scaled level that customers need. Now the developers and the testers and data scientists are able to run at the speed that the business is running with that data. They're not held back by it. And then we start talking about what things look like from a self-service portal from a developer standpoint or from a data scientist standpoint. I had a lot of developers and testers who were coming to me and saying, Kellyn, I just deleted 1.7 terabytes of data in this environment. Can you please put it back? Kellyn, I screwed this up. Can you please fix this? Being able to fix that yourself makes it much easier. So inside the self-service portal, what you're going to see is that you've got a branch. This is a new database, new virtualized environment. This is the application tier, database, any flat files, whatever you want to connect into this. I would then do a next release, and I can bookmark this. It doesn't mean I'm locked into that bookmark. It's just saying this is an important change that I made in this environment. They do another one, and the natural progression would be, now we've released to production, we do a new branch, and we start over. But let's say it didn't go right. So they would be able to just take that little slider that's out at the end and move it back. I would be able to control forward and backward, and it would roll back everything. The database, the flat files, any application changes, all of it, to that bookmarked state. So the database you would see go through a recovery method and recover back to that point in time. Any of the flat files would actually go back to what they looked like at that moment. There are those little bookmarks that we have taken, and there is an engine, and I'll tell you straight out, our engine has a Postgres database on the back of it, but all it's doing is tracking what were the headers on those files at that moment. Put them back, leave them the way they were. And with that, I could even go forward maybe 3 steps, 4 steps. It doesn't require a developer or tester to know how to flash back a database. It doesn't require a developer or tester to have access to a server. All they have to do is just move these sliders back and forth. And this seems to really do a lot so that your sprint goals are able to be met. The data is able to keep up. They're not having to coordinate with all these different folks. They're able to just say, we've got a problem here. We need to go back and go forward the right way. The next step we're going to talk about here is confidential data. As I was talking about, GDPR is coming up pretty quick. A lot of times companies don't think that they're subject to GDPR. I will tell you, even my blog is subject to GDPR. If you're collecting cookies, if you're collecting the URLs, IP addresses online, this is data that needs to be tracked. How many of you are seeing emails coming in telling you there've been an updated use on the different sites they're going to? Oh, you've got to be seeing them. There's tons of them. I'm getting so many of these right now. I'm like, did I even sign up for this site? I don't remember it. There's so many of them. But I had to go after even my web guy at Delphix and go, we are GDPR compliant. And they're like, what do you mean? It's like, we are a GDPR masking company. We better be GDPR compliant on our website. These are important things, recognizing how much of this data is actually incorporated in this, that you have to be able to not just review the data, you have to audit it, you have to be able to update it and delete it. We're not real sure what that means for anybody working in blockchain. Really sorry if you're there. That's all I gotta say. It's a scary situation. But the way that I'm looking at this is that, there's so much of the data is non-production. And if you were involved or saw the Target breach, it was a non-production database. Somebody got in that way. So you start realizing how vulnerable a lot of your non-production data is. I've been on the Caltrain where there were some data scientists sitting behind me, and they had printed out their actual test data, and they were telling the other people how it was real data, and they needed to solve a problem. And I recognized that there was this huge pile of critical data sitting printed out on a train. You recognize how vulnerable this is, and they didn't have any intention to create this breach or intention to create this vulnerability. They just did it trying to solve a job. So with 20%, let's say, of your data being production, another 80% is non-prod. Another 80% doesn't actually need to have that vulnerability in there. So encryption is necessary. Encryption is everywhere right now, but it is reversible. If you have the key, you can get to that data. Masking is non-reversible. Masking can be used with all these complicated, it doesn't matter if we're talking about Net 2000, Optum, any of these, Oracle, they have very complex algorithms and repeatable processes that go in, mask the data numerous times to ensure that it's not reversible. It makes it much more secure, much easier to utilize, and yet they still have referential integrity, and it understands the foreign keys and everything else if you're working with a product that's built for that. What you're gonna see is something that looks like this, and I'm gonna tell you straight out, anybody who says they can do this and they don't need a separate engine to virtualize your data and actually mask the database, they are lying to you. It takes a lot of juice to do this. So I always draw out this diagram so people can understand this. I would keep a separate engine to virtualize the data versus what is masking the data. I would do it before I ever go outside of that environment. And then I would be able to deploy it to the cloud, and it would never be vulnerable to begin with. We can be happy with encryption, we can be happy with extra security, but I would rather not have that data vulnerable to begin with. And 90% of the cloud environments right now are non-prod. It's mostly new environments that are actually going out in production. So the ability to mask this before it ever goes out makes a big difference. And what you're gonna end up is looking something like this. Your solution on the right side here, you're gonna be encrypting your production data, you're gonna be masking your non-production data, so you don't have to worry about it. So what does this mean? For our data ops summary here, it's talking about moving that data as fast as everything else is going. It's talking about virtualizing it. It's talking about not having to have the entire file, but just the header on those files to create a virtualized environment and do it over and over again so that everybody has their own environment. DevOps requires this because there's usually so many different Scrum sprints going on in projects and everybody's doing something different. The ability to merge those later on are very easy to do, and you're able to virtualize these environments straight through. For the company that I was talking about, were their goals achieved? And they were. We were able to actually create a DevOps environment for them that created about 300 databases on average every week. They were able to move very, very fast. They have a nice new office down in Denver, downtown, looks very nice. They automated everything behind the scenes. They escaped a lot of the data gravity they were feeling because their databases were growing so fast. They were feeling a lot of this pain, and as it grows, it's able to scale as well. They just add more engines as they need to and add more memory and CPU, but they're not finding the demands that they were before on the disk space usage, which was one of their primary situations that was holding them back. They were able to encompass data ops into their DevOps scenario, and it made a huge change. Dave's company saw a 10% increase in their data accessibility, and it ended up acquiring about $65 million in revenue changes because of this. This is the average that we're seeing, and they pinned right down the middle on this. So they were very, very thrilled with that. By embracing it, it removed that last hurdle that their developers and testers were actually feeling. They were using the containers. They use these templates so that the developers can actually request an environment when they need to. They just say, I need a new development environment to look just like my development that I have. They put in a few little things and it's out there for them. They have tools and an interface that makes life easy, and it works with their other tools that they chose. If you're interested in learning more about this, I have a lot of blog posts that I've written about this solution and where they've been going. Also, if you're interested in learning about DevOps, have any of you read the Phoenix Project? Do I have anybody? I got 1, 2. It is an awesome book. It's like $4 on Amazon. It's really inexpensive right now, from Gene Kim. It's a great book because it kind of gives you that solution and understanding of DevOps, but from a novel perspective on manufacturing, a manufacturing company, which is awesome. And if you get through that, then you can go into the boring stuff and start looking at the DevOps handbook. But these are great books to really get you up to speed on where DevOps is, and then how DataOps fits into that, because anybody who's working with data will feel this pain point. With that, are there any questions at all? Please.
Are your slides available?
They will be. I am going to upload this new set. I took a few things out to fit into the 45 minutes, but I also added a few things in.
So the whole thing unedited is going to be up there? Right?
Absolutely. Any other questions? You guys are like ready for lunch. Please.
My question is, in some platforms, e-commerce platforms, sort of vertical platforms is what I'm thinking about. Data loading is something that is part of the stack. And I'm relating to the experience you're talking about here, but the problem we had was you're loading into the proprietary environment sometimes. So what best practices or what things from your kind of list of methods or ideas do you think are independent of platform? Do you think are going to make sense even when you have to deal with sometimes with proprietary platforms, commercial platforms, cloud? Think of Salesforce, think of Hybris, things like that.
So we do virtualize a lot of Salesforce platforms as well. The challenges that we saw was when they were moving from one cloud to another, and if you're doing data loads and everything else the way that you've always done them, you're going to feel the pain once you go to the cloud. You really are. Anyone who says, oh, I'm going to go to the cloud, I'm going to save money, they're lying to you. You're not going to. It's going to be a smaller cost, from the start out point, but once you get up there, it can be challenging. So to have a D source that you're loading in once and then virtualize from there, it's just kind of thinking outside the box and how you've done things the entire time. A lot of times people were loading schemas in certain databases, and we said, no, just virtualize the environment and drop the schemas. It was just rethinking how you did things to have less data in flight, less data transfer between domains, things like that. That is the most important choices I think you can make as you start working with products like that. Hope that answered it. Any other questions? I'll let you go get more coffee. Thank you so much.
Thank you. Good job.